This project is about IoT based food monitoring system. This project is done by Christina Sharon and Adina Sneha under the guidance of Mr. Stuart Kirubagaran. So the project goes like this. IoT based food monitoring system. So the problem statement is the food wastage is a very big problem in today's world, and majority of the food gets wasted in any one of the supply chain process. So what is supply chain process? The supply chain process is nothing but the production, packaging, and processing, storage, wholesale distribution, retail distribution to customers. All those are five stages of supply chain process. In each of these stages, there may be a chance that can get spoiled. Even when it comes to customer, at last we may find a defect in the products. For example, take a chip packet. Uh, there may be chance that the expiry date is wrongly printed, and the consumer gets to eat it, and that may lead to various diseases, including the person getting affected by Shigella bacteria. Okay, so to avoid this, food monitoring system is introduced. So the requirement is the input from the data sensors are collected, and it is sent to the cloud via an API key uh, that is obtained from ThinkSpeak, and the data gets visualized as a graph in ThinkSpeak, where the user gets to know the amount of temperature, humidity, and the gas value. So these things we are going to analyze it and predict whether the food is spoiled or not. When the collected data exceeds a threshold value, the food is predicted to be spoiled. When the food is predicted to be spoiled, an alarm is triggered and the user gets a notification using IFTTT. If this then that protocol, uh, the user gets a mail saying the food is spoiled, and they even get the spoilage rate also. So the tools used here are MQ3 sensor, Arduino Uno IDE. The ESP8266 module used here supports Arduino IDE. So uh, we are using that. Arduino IDE is inbuilt inside PC. For typical Arduino Uno, we need to be converting analog signals to digital signals. To avoid this, we are using the PC-based supported Arduino IDE, which by itself has digital signals. So the typical food processing system has LCD display for displaying the digital signal, but here we are using ThinkSpeak to visualize every output. So the IoT used here are Node MCU and Arduino Uno. So the methodology is the same I have explained. So the sensors and hardware used are DHT11 sensors and all those things. So here the food spoilage process. Whenever the food gets spoiled, it gives out methane gas. The methane gas is uh, sensor data is collected in by gas sensor, and that same is visualized in graph in ThinkSpeak. Okay, let's go on to our program. So I am using Arduino IDE for this food monitoring system. As said, Arduino IDE is supported by Node MCU ESP8266 module. So let me try the program. So once the sensors are connected with this laptop and Arduino IDE, we get the following output. We get the recognition of the modules which we have connected through Arduino IDE. So it says the port which it is connected is on COM3, and the chip and Wi-Fi available, everything it has recognized. And we also get the temperature, humidity data here in the serial monitor. This is the serial monitor. We also get that output. Okay, this is the program. So here we have installed all the libraries. The installed libraries can be seen here in the library manager installed, and we can see how many libraries are installed. So we have defined all the library files. These are the installed libraries, and the SSID and password. SSID is nothing but the Wi-Fi connectivity. So my SSID is nothing but my Wi-Fi name. So the range of this Wi-Fi must be uh, converted into 2.4 GB because ESP8266 does not support 5 gigahertz range. Next, we come to the setup. The main function of this program is setup, and next it follows with loop. Loop is considered to be similar to looping functions in C++. So the program is written on C++, while OOPS concepts and the concepts related to OOPS and some other features are not available in Arduino IDE programming language. So here we are going to check whether it is equal to the serial. If it is so, the clients get notified, and under loop we are going to check whether the password and SSID matches with the password and SSID of our computer, and if it is so, it gets connected. That's why we are getting the output connecting, and it has recognized. That's why it has sent an acknowledgement message saying the feature is Wi-Fi and other features of the Wi-Fi. The next we are going to get temperature and humidity values, and the same is printed here. Next comes the uh, ThinkSpeak program. Under ThinkSpeak program, temperature, humidity and are set, and the methane value is also set, and the ThinkSpeak displays all those values in ThinkSpeak. This is ThinkSpeak. So the temperature data and the uh, food humidity data, this is at shown here. Let me refresh it so that we get the current value of the temperature and humidity. So that you can see the temperature at Saturday, January 8, 28, 13/8, that is now 1 p.m. is monitored, and the methane rate is also set. Then comes the humidity rate. Now coming to the sensors and how it's set up. Let me show it. So this here is the node MCU, and this is the gas sensor. This is the gas sensor, and here I have uh, kept candy, this same candy, kacha mango bite, so that it will detect the food spoilage in that. And this is the node MCU. Here, as you can see, this is the node MCU. So the D0 pin is connected to the temperature sensor. The temperature sensor is here. This is sensing the temperature and humidity. This is called DHT11 sensor. And in this node MCU, as you can see, there is ESP8266 module. This chip is called ESP8266. So this is a model. This is a model of the final customer face. when the customer gets to buy the product. So this is how it will be. We can always predict the spoilage level in a packed good, like a chocolate or chip maybe. But for unpacked foods like apple, oranges, and the rest of fruits, it is difficult to uh, predict whether it's spoiled or not. For that, especially this food monitoring system is used. So, uh, this is how the final supply chain process will be. For this final chain supply process, also, this food monitoring system can be used. So, thank you. Under the literature survey, the already existing food monitoring system has been analyzed. Some of the food monitoring system has used LCD displays, and some has used supply chain monitoring, uh, and they have used both for their telegram application. But in our project, we are using IFTT, which is advanced, and here this food monitoring system uses alcohol, is used to find the alcohol content, and here it is manual monitoring in food warehouse. So these are the existing, and ours is uh, the